I will travel where no man has dared to go.
The accepted laws of physics break down.
Boundary between the known universe and a place beyond the reach of science.
We're going to talk today about... Hello everyone. We're going to talk about how to handle vectors when dealing with forces and how to think in the correct manner so you're able to use the calculator as a tool and not a hindrance. So the first thing we want to do is think about what do we know about these quadrants. Right? We have first quadrant here, and we know that based on our coordinates, right, our x will be a plus and our y will be a plus as well. So over here we have quadrant 2, and then quadrant 2, our x will be a minus and our y will be a plus. Right, we're heading in, we're starting in, this is our point of origin always. This will be quadrant 3. Okay, and in quadrant 3 we know we have both of them are negatives. And in quadrant 4 we have a positive x and a negative y. And remember, once again, these just tell us direction. X-wise, this is positive. X-wise, this is negative. Y-wise, this is positive. Y-wise, this is negative. Alright. Now, we're going to be skipping in between using it's just the standard components of the force as well as using angles. So I have to set my angles right. So we know I have this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then of course that comes back to 360 degrees. Oop, that's supposed to be a 3. 360. And then the final thing I want to just call out to you is that it is important for us to really understand our numbers, to think about cutting all of these little quadrants in half as well, because we're dealing with component values. So I know if my forces are balanced, if the numbers are balanced, I'll get an angle of 45 degrees right there. Right, that's perfectly in between the 0 and the 90. On this side, the other magic number that we want to pay attention to is going to be 135 degrees. And then over here, our other magical 45 degree mark is going to be at 225 degrees. And then finally over in this area is going to be 315 degrees. Okay? So all of these are numbers and everything we should know about our coordinates. We're creating a map, a logical map. So in this case, when we're dealing with forces, it's always important to remember in physics, you have to make sure that you're telling the numbers what they should do to make sense. Right? We deal with different types of numbers all the time. You have to be in charge of the numbers. So, alright, let's get this problem started. So, let's see. I'll go over here and I will pick... Let's do red for now. So, let's say I have a force, okay? And we're talking about an object we might be acting on. So, let's start there. Let's start by thinking that, alright, so we have this hockey puck in the middle of an ice skating rink. Okay, and two people are going to hit the puck at the same time. So it's a face-off. So in the face-off, the red team hits it, and when they hit it, they go ahead and they give it a certain force. So let's say that they give it a force of 49 newtons, and they applied that force of 49 newtons at an angle of 30 degrees. I'm not very good at the 3's in here, apparently. Let me see. Theta. Okay, good. So that's our first force. All right. Our second force now, let's say that the green team, they also hit, but when they hit it, they hit it in this direction. All right, and they are at 150 degrees from 0. So it's actually from all the way over here and down 150 degrees. And let's see, they've applied a force of 29.4 newtons. Okay? So the first thing we want to do is, we can't just add these together. See how unbalanced they are? One's at 30 degrees and it's 49 newtons, and that's 29.4 at 150. They're not on equal playing grounds, right? They're not equally matched, so I just can't simply add them. So what I have to do is I actually have to go and we'll start with this one here. We need to break it down into its components, and by components I mean that it's going to have an x value and it has to have a y value. Okay? And this is what makes up, if you think about it, that 49 newtons. But more importantly, this is a math operation I can use to make this less complicated, right? We know there's a pulling force in this direction. We can see that, and because it goes up, there's a little bit of a pulling force in this direction. So the first thing I'm going to have to do is either sine or cosine. So I'll do I'll do both. I'll do the sine and cosine over theta times, and we'll do our hypotenuse, okay, which in this case will be our 49 newtons. And I'll do cosine as well. Now, I have often found it, once again, I actually want to get things solved. I use this for everyday life. So I'm not really going to sit there and try and figure out the triangles all the time and where they're at. So instead of doing that, I'm going to just simply let my calculator be a simple little tool I use, and I'm going to use logic to place my answers where they should be. So I'm not even going to think about which side is my adjacent, which side is my opposite. All I'm going to do is go ahead and hit sine and cosine in here. Okay, so I'm going to do sine of theta times, so sine of 30 times 49 newtons, and then I'm going to do cosine of theta times, so the cosine of 30 times the 49 newtons. And I'll get two different numbers depending on what I do. So if I do that, I get 24.5 for my sine. Alright, and that's newtons, 24.5 newtons. And, I'm sorry, 24.4 newtons. Oh no, it was 5. It was a 5. Alright, there we are. And then the other one's going to be 42.4 newtons. So let me go ahead and erase that. So they're nice and legible. And once again, all I did was either sine or cosine, okay, and I got two values. Now here's the thing, you can try and keep track of them and say, oh, which one's which, but in reality, whoops, erasing a little bit of my border there. In reality, the simplest thing for me to do, actually, is just to write down those two numbers and logically place them. So like I said, my one value I got was 42.4 newtons. This one was 24.5 newtons. Alright, now so logically thinking about this, I look, and this is at 30 degrees. So it is below this 45 degree mark, and I know that I will always get a perfect 45 degree angle when I have balanced forces, or if I throw something with a perfectly balanced velocity. So because of that, 42.4 newtons, this is the bigger number. So if I think about 42.4, well, it's closer to this. So all of the force is being directed more onto the x. So I know right away, just using logic, 42.4 newtons has to go there, and then that makes my y 24.5 newtons up here. And once again, I'm just looking at the fact that this, if I aimed it, when we studied velocities, when I aimed the cannon, right, the higher I aimed the cannon, the velocity out was always the same, but as I changed my theta, my y component, If it went up and above 45, my y component was greater than my x. In this case, we're below 30. So when this person hits it, they're putting the majority of the force in that direction. And we've broken it up into x components. Right, so down here, I'm now saying that this part is worth 42 newtons going in this direction. 42.4. Okay? And that means from here, in terms of a y component, line's not that straight, but this should be 24.5 newtons in that direction. Okay? So those are just my two for that area. Now I'm going to go over to the green team. I'm going to do the same thing again. I'm going to get ready to calculate my x and my y. I'm just going to do the sine and cosine of both. And when I do the sine and cosine of both, I get to see that I have one number that is going to be 14.7 newtons. And all I'm doing once again is just taking my theta, so the sine of theta, right, times 29.4, and then I'm doing the cosine, and the cosine of theta should be 25.5 newtons. Now, when I'm working, remember I said before, we're in these quadrants. Right, we're in the second quadrant, I know based on the angle that it's over here. And we said earlier that my x would be a negative number and my y would be a positive. Well, now if I look at this, I have two sets of reasoning and logic to know where my number should go. The first set is that I know that one of the numbers should be negative, and oh, that's my negative, and we said earlier that should be our x, right? That's the negative quadrant for the x. The next thing I think about is what number should be larger. Okay, so first I look at the signs. This one's saying that it should be x, but now looking at what number should be larger. Look, I said before the magic number over here, the 45-degree break, in this quadrant is 135. We are below it, which means we're closer to 180, and that lays on towards the x coordinate, my negative x. So now I have two things that match up. Number one, it's a negative number I got, and number two, it is also the larger number. So that means that this right here is going to definitely be our y, or 14.7. Okay, so now when I look at these numbers, right, I had a positive 42.4 newtons pulling in that direction. I have a negative 25 pulling in this direction. Forgive me, my scale's a little off there. And then we just said we have a y also going in this direction of 14.4. I'm sorry, 14.7 newtons. So now if I think about it and I look at these things, here the red is going in this direction, or in the x, the y is going on this direction, or I'm sorry, the x is going in this direction for the green team. The red is 24.5 newtons in that direction, and the green also is going 14.7 in that direction. So now all I have to do is, like I said before, I couldn't add them up when they were in their degrees and their resultant form. Now, because I know their components, I can show them as directly opposing each other or directly working together. So now all I'm going to do is I'm going to get my x totals. So in that case, this should be a t, my x total. I'm taking this x, and now we'll call this x2, and we'll call this x1. So first this is y1, and then this is y2. So all I'm going to do is take my x1 value plus my x2 value, and then over here I'm also going to do my y total will be equal to my y1 value plus my y2 value. Okay, so when I add up my x, when I add up the the 42.4 plus the negative 25.5. Let me try to get a new color here. I'm running out of good colors. Maybe yellow. Will it show up in yellow? I get a total that is 16.9 newtons, and I get another total for my y that is equal to 39.2 newtons. So that means that when I look at this, my total directions, right, on my x, these two canceled each other out, and I'm really just left off with this. A value that goes in that direction, right, that is the total of the values, and then it only has a pulling force or a force in that direction of 16.9 newtons. In the other hand, this one adds all together to give me a total that is 39.2 newtons. So now if I go to, if I want to find the resultant, I'm simply going to use the Pythagorean theorem. Right, my Pythagorean theorem, because if you look here, I got to get a bit of a triangle going right in that direction. But I want to see the resultant, so we're going to do more of the reality of it is a tip to tail, where it's going to go like that. And we would see it go out in this direction. So that's the real triangle there that we would see. But because I had them up on their axes, I did it originally like that. So my overall force would be in this direction. Oops. So that's what we're going to look for right now is the resultant. And going back to it, we will see that is simply the x total squared plus the y total squared, right, and the square root of that. So when you take the two together, you get a resultant force of 42.69 newtons. So that total going right here, this blue line, is going to be 42.69 newtons. Now remember, this resultant will not be a negative or a positive number. Why? Because we still need to find our angle. So our theta, we need to find out what it's leaving from right here. Okay? Now, for this you'll use, you can use any way to get there to get your resultant, but just make sure it makes sense. So I'm going to use my inverse tangent. But before I punch any numbers in, I'm going to think about it. So again, I can try and figure out the triangle, but we said there's a triangle up here, there's a triangle up here, and it can get really confusing. Here's what I know. I know that this 39.2 is a larger number than the 16.9. So therefore, because it's a larger number, I know I'm going to be above the 45-degree mark. So now I can make sense of it. So whether you put one number over the other or however you do it, you'll get two results. So if you either do the inverse tangent, you get 16.9, right, over 39.2, or you do 39.2 over 16.9 with the inverse tangent, you should get two numbers that you can make sense of. When I do that, the first number I will get is 67 degrees. The next number I get is 23 degrees. Now, the reason that this is important is your calculator is not intelligent. Right? If I flip things around and I flip the opposite of Jason, it doesn't know. All it knows is that I'm always setting my x or this y as origin. Okay? I'm still setting one of those points. So now if I go to make sense of my number, which number would it make sense that it was actually the theta of it based on this 0-degree mark? And you know what? It's 67 degrees. It's above my 45. Right? It's above my 45. At 67 degrees. But here's something neater. Like I said before, it doesn't know whether you're here, but if you mess things up, it thinks that it starts you here and it treats that like it's this origin. So now watch. All I would do, even if I just did that one and I saw that number right away, all I'm going to do is subtract that from 90. So I take 90 minus that 23, because I know that number should be somewhere in between 45 and 90 based on the components, based on 39.2 being greater than 16.9. So all I do is 90 minus 23 degrees, and you know what you get? You get 67 degrees. So try and make sense of this video. This is good logic. It is not fighting with your calculator. It is not assuming your calculator will do things. It is a logical reasoning, and the only time I ever really used my calculator was just to find the sine and cosine of these, but I didn't want to struggle with which one was which and trying to make sense of it. All I did was just simply apply logic based on the angle and the components of it and what it should be.